I am going to use the Chapter 16 Data Set 1 for this example on how to calculate or compute the regression line in SPSS. So to do this, first you're going to open your data set, so take a minute and do that. You can pause the video if you need to. And then we're going to go to Analyze, Regression, and under Regression we are going to do a linear regression. And for our purposes, we will be doing linear regressions in this class. And linear just means we're looking for a line. So click on linear regression. And within this menu, we need to choose our independent and dependent variables. In this situation, we're looking at the number of hours per week that a person is strength training, and then the severity of their injuries on a scale from 1 to 10. So does lack of training increase injuries, or does more training increase injuries? So we want to see what that prediction is. So to do that, we're going to use injuries as our dependent variable because our severity of injuries is dependent on our training. And I'm going to move training into our independent variable. So go ahead and do that. And then you can go ahead and just click OK right away. Those are all we need to worry about. There's a lot more in SPSS, but for our purposes, that is what we need. And you are going to get quite a few different boxes here of data, as you can see under regression. And the major box we're going to look at, well, there's two boxes. The last box of coefficients can be important, but for our initial purposes, we're going to look at this model summary box right here. Let me see if I can, hope I can't open that. And under there, we're going to get a value called the R-squared value. The R-squared value tells us how strong our regression equation is. In this case, we've got a 0.21 R-squared value. That basically tells us that 21% of the time, if I use that to predict a value, 21% of the times my prediction will be correct. As you also can see in this model summary box, I have an R value, this 0.458. That is going to be my correlation. So that tells me that my data has a positive relationship, but it is maybe moderately to moderately weak relationship. To actually calculate your regression equation, you will actually use the coefficients box. The coefficient box tells us what basically our slope and our intercept values are. Our slope value is this bottom value here under the B box. At negative 0.125 is our slope value, or the number that goes in front of our m. So our slope, our equation is going to be y equals negative 0.125x plus, and then our y-intercept, which is your constant value here, which is your 6.847. That is the equation you would use to predict. So if I knew that I was training for 20 hours a week to calculate the severity of my injuries, I'd plug that in for x. So I would have y equals negative 0.125 times my 20 hours, because I'm going to use that for my x values. And then I'm going to add on my 6.847, which is my constant. And when I plug that in, I will get a number that would indicate the severity of my injuries. Now again, in order to do that, you need to use this R-squared value here. And that tells me that when I plug that number in for x, I will probably only be correct about 21% of the time. Now to continue on with regression, not only do we want to figure out the R-squared value in the equation, but we also should look at it graphically to see how our line fits our data. So to do that, we are going to go to Graph, we are going to go to Legacy Dialogues, and we're going to choose the Scatter Dot option. In here, you're going to want to click on this Simple Scatter, and then click Define. In the y-axis, we're going to choose injuries because that is our dependent variable. Our x-axis, we're going to choose training because that is our independent variable. And we're just going to click OK. And that will give us a very basic scatter plot. Now looking at this, we can see why we did not have a very high correlation. Our data is very spread out. There's not a real good indicator of values. But to draw the regression line within the scatter plot, you will double click on the scatter plot. And you're going to get this little properties box, which allows you to edit. That did not work. Here we go. So within this one, you want to choose the Add Fit line, which is at the total button. So if you look in here, there we go, I couldn't find it either. On this bottom menu here, you're going to have this little bar, and you can see the regression line drawn in there. So you're going to click on that. Hopefully you can all see that. It's Add Fit line at total. And we're going to choose linear regression. And as you can see, it's already in there. So you can go ahead and hit close, and you can see our regression line is already drawn in. Once you click on this little chart, this little button here, it's already drawn in. I think we can just close that, and there we go. It puts it right in there for us. So here is our regression line. Notice it's a negative, which it should be because we had that negative slope. The nice thing when you do this is it also gives you that regression equation, so you don't have to go dig that out of that initial coefficient box like we did up here with the 6.847 and the negative 0.125. They obviously rounded the negative 0.125 to the negative 0.13. But you can just give me this regression equation here. That way you don't have to worry about going through that huge, long process. The nice thing with the graph also is it gives you this R-squared value. So honestly, if you skip the whole regression analysis and just go straight to doing the scatter plot and adding the line of best fit in, you will get your equation and you will get your R-squared value, and you don't have to go dig through the tables. So either method is fine. I would recommend using the second method where you just did the graph and found the line of best fit. For your homework, make sure you copy and paste this chart over as well.